Hello, my name is Luis, and here I will describe the functionality of my project for the first challenge of the course, Introduction to Artificial Intelligence with Python. So the assignment is to write a program that determines the degrees of separation between two actors, in this case Emma Watson and Jennifer Lawrence. So to do that, we modify the shortest path, which is a method in the provided code. So in order to explain the functionality of my algorithm, I'm gonna go through an example from the small dataset. So we define Kevin Bacon as the source and Tom Cruise as the target, and they both started in A Few Good Men, which is the last action before getting the goal. So let's go through the steps. First of all, we start with an empty queue frontier. Then we added the initial state. Also, we create an empty explored set, and then we go to the main loop. We check if the frontier is empty, but it's not the case, so we move on. So we remove a node from the frontier and add it to the explored set. Therefore, we expand the node by getting the neighbors, but here is important to clarify the functionality of the neighbors for person function, because this returns all the stars in the movie, including the current node. So as you can see, we have Kevin Bacon, even if it is twice, but it's not like something that we need to care about because we lead with it on the following steps. So just keep moving. We check for each neighbor if it contains the goal state. So in this case we were lucky and the goal state was in the first neighbor. So in this case we finish the program and we just return the solution. But what will happen if we just define Jack Nicholson as the target? So well, let's see. We just keep going with the loop. We add the neighbor nodes to the frontier if they aren't already in the frontier and in the explored set. And then we go through this little loop for each neighbor. So we check if the neighbor Demi Moore contains the goal state, but it's not the case. So we just add it to the frontier and move on. And then we got to the goal. So we return the solution and finish the program. But what will happen if we just don't find the solution in the first level? So what will happen is that we keep going to the main loop, and just remove the nodes from the frontier and repeat the process. Well, finally, I want to mention that I tried two different approaches. So the first one, I checked if the node contains the goal state just after removing it. But in the second approach, I checked the goal state for each neighbor, so it optimized the algorithm by returning the solution without adding the neighbor to the frontier. And how is this reflected in the results? So as you can see, the first approach required more than 500 seconds to compile, but on the other hand, the second approach, which was the suggested in the assignment, it was less than 2 seconds to compile the same scenario.